Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is again about flying close to the surface of the ground, where we have constant acceleration g, and we're throwing different objects. And in this case scenario, let's say we have an incline, and this incline has an angle alpha, and we're throwing the body this way horizontally. And they want us to find, for example, this distance d. This distance d when the body will fly and touch this. And how we will solve it? First of all, we can put here y, and here we can put x. And this is a body thrown at angle 0 to the horizon. It's still two-dimensional. It still will go in this direction with v0, constant speed, and it still will fall down with acceleration g directed down. And still, as we know already, this would be a parabola. I can continue it here. This is invisible part. This never happened because time starts here and this is negative time, but in principle this would be this parabola. But we have to solve it now, and let's solve it. So I suggest we write x equal v0t. Remember, previously there was a projection v0 on this x, and there is no projection now. X equal v0t, with going this with this direction. What happens with y? Our initial, the formula, of course, y0 plus v0t plus at squared, and we have to operate this. y0 is 0 because we're starting here, so it's not there. Initial speed in this direction is 0, it's free fall. And so acceleration axis y is directed up, and hence it would be minus gt squared over 2. Acceleration is negative. Of course, if you so prefer, we can here draw the axis in this direction. It's our total will where we direct our axis. So we direct it down, and then g is going together with this arrow, and this would be plus. Okay, and so this is two formulas that describe the movement of the body. And also, they want us to say that we meet here, and they want us to find this distance. So we can say that this thing on this incline, the fact that this on this incline means that here x and here y, and they both the same because I'm looking specifically for the point where they meet together. So I want to say that x is this, y is this, and they also belong to this line. And what that means? That means that y equals tangent alpha multiplied by x. This is the equation of this straight line, because this is alpha. If this is alpha too, between this incline and horizontal axis. So tangent alpha multiplied by x. We take this, or we can find it from here. If we take this triangular, we say that this is y and this is x, and we say y divided over x, what's on the opposite side of this angle is y, divided to the what is adjacent to this angle, and its definition of the tangent. And if we send x there, it's exactly the same function. Or you simply can remember that this is a straight line, and if this is angle is alpha, then tangent alpha equal x. Of course, if I would draw like this, then this would be negative, and here would be negative. It would be two negatives, because it's positive only because this direction is this way. So as x grows, y grows. This is all the point on this line are described with this equation. And all the points on our parabola, because this is a parabola, we know it, are described by those two equations. So we have three equations, right? And this is line, and these two are parabola. And we have three equations, and we have tx and y, and we can do whatever we want. For example, we can get rid of t and get rid of x. Let's first get rid of x and then get rid of t. So we put x in this equation, nothing, and we put x here. So this is gone, and this becomes y equal gt squared over 2. And this becomes y equal, and there is positive because this is this way, equal tangent alpha, and instead of x I write v0t. And this is two equation, and I get rid of y. How I get rid of y? I put this y here, and there would be no y, and I have gt squared over 2 equal tangent alpha v0 and t, of course. And let's say I move it all to one side. Of course, you want to cancel t. It's possible, but you have to remember that t is not equal 0. And when t is equal 0, those two lines, parabola and this, are intercepting 2. So if you say t is not equal 0, so you exclude this point, which is kind of obvious, then it's fine. But you can also move it to one side and multiply by 2, and this would be gt squared minus 2v0 tangent alpha t equals 0. So I multiplied by 2, and I moved it here, and it becomes negative. And I can take out t, and I can say gt minus 2v0 tangent alpha equals 0, and first solution is t1 equals 0, we talked about it, and second solution when we be on this bracket would be 0. So I say gt here, this goes to another side, 2v0, no t, 2v0 tangent alpha, because there is no t. T is already factored out. Okay, and t2 equals 2v0 tangent alpha divided over g. That's it. And this is second time. And this is exactly the time when this happens. So we know the time. We can find from this time, we can find this x, and we send this here, straight here, and let's call this x because it's not like some x, it's length L. So we say L equal this thing, it would be 2v0 squared tangent alpha divided over g. Okay? And if they want us d, we know this distance, and we know this. So we of course know from this triangle or you should look trigonometry playlist. I talk about those definitions of sine and cosine. But basically, this L divided over D hypotenuse equal cosine. And if this is the case, we can, well, let me remove this. If this is the case, we can find D. We send D here, cosine we send here, and we say D equal L divided over cosine. And we substitute this and divide, and so we have 2V0 squared, and here we can write tangent alpha divided over G cosine alpha. And if you want, we can split tangents as a ratio of sine over cosine, and this will become 2V0 squared sine alpha divided of G cosine alpha. And basically, that's it about this problem. But of course, you can have this problem in various verbal arrangements. For example, they may say, this is a swimmer who jumps from the trampoline. He jumps in this direction and he lands here. And this is water, of course. So he lands into the water and they will give you D, or they give you L, or they will be asking you about L, or maybe they want to know H, how high he will jump. All of this can be achieved with the same logic. Axis, and you feel free how you want to put the axis, this way or that way. And you calculate it the same way. Acceleration this way, constant speed this way. Formula for constant speed is this, formula for acceleration is this, and this is the point of intersection with this line, but everything should be there. So in principle, this is valid for any time. But if you want specifically the time when all this happened, in principle, you can write, instead of x, you should write L. Instead of y, you should write this h. Right? This would be all valid. Instead of time, this would be t, the time when all this happens. And of course, y, this is h, this is h, and this is h, and this is tangent alpha of x, and x is L. And so this is like different letters, but absolutely the same principle. You will get rid of L, you will put it here, you will get rid of H, you will come to the same absolutely equation, and you will have time, and after you find time, you will find L from this formula, V0 multiplied by T. I removed time already, wiped it out. And you have all the pictures that you want. It's like different wording, but the principle is the same. And next installation, I will look on this problem yet in another way, and it may be useful for you. And if you liked, like. If you want to see next, subscribe bell. If you have a question, ask the question. See you next time. Thank you.